Hello everyone, my name is Isman Alimdin. Today I will be representing the fundamentals of computer systems, networking and data representation. My presentation covers 13 major areas, ranging from the internal architecture of the CPU to the physical layout of computer networks. The CPU consists of several key parts: the ALU, the control unit, registers, the clock, the bus interface, and cache memory. This slide shows the 6 internal components of the system. Together, they represent how the system is structured and how the main functions are organized internally. The arithmetic logic unit handles two main tasks: mathematical operations like addition and subtraction, and logic operations like comparing data using AND, OR, and NOR gates. Registers are tiny, superfast storage locations. They hold the specific data and instructions the CPU is currently working on to ensure zero delay. The control unit is the director. It decodes instructions and sends signals to the rest of the hardware to tell them exactly what to do. Cache memory is a small amount of high-speed memory that stores frequently used data, so the CPU doesn't have to wait for the slower RAM. The bus interface is the communication bridge. It moves data between the CPU and other components like the RAM and input-output ports. The system clock synchronizes everything. It sends out pulses. The faster the clock, the more instructions the CPU can process per second. This slide explains the main function of the CPU. The CPU is responsible for processing data, executing instructions, controlling system operations, and coordinating between different hardware components. The first step of the CPU cycle is fetch. The CPU retrieves an instruction from the main memory RAM and brings it into the processor. Second is decoding. The control unit breaks down the instruction into a format that the CPU's internal circuits can understand. The third step is execute. This is where the ALU performs the actual calculation or the data move requested by the instruction. Finally, the result is stored back in the memory. Throughout this, the control function ensures data flows to the correct hardware without errors. This slide shows how different hardware components work together to process data. Input devices send data to the CPU, which processes it using memory, and the results are shown through output devices or stored. The CPU does the thinking, but it needs a workspace. RAM provides that space, holding the programs and data currently in use for fast access. While RAM is temporary, hard disk drives and solid-state drives provide permanent storage for your files and the operating system even when the power is off. Motherboard provides power and connects all internet components for communication. PSU converts external electricity into the specific voltages required by components. GPU processes visual effects, images, and animations. Input and output devices are used to feed data in and display generated results. This slide explains different types of storage media and their purposes. Each type is used based on factors like speed, capacity, cost, and portability. Hard disk drive is used for long-term storage of the operating system and large file at a low cost. Solid-state drives. Solid-state drives are fast and reliable storage with less power consumption, ideal for laptops and gaming. Floppy disk. Floppy disks are early method for saving small files and transferring data. Drives. USB are used for running portable apps, creating bootable drives, and temporary backups. Optical disc. Optical discs are used for archiving data and distributing multimedia content. Memory card. Memory card provides secure storage for portable devices like cameras and drones. In computer systems, all data is represented in binary form using zeros and ones. This allows computers to store and process information electronically. Data representation allows for efficient processing, storage optimization, and error handling. Efficient processing. Proper representation ensures data is processed quickly and accurately. Storage optimization. Compact formats save storage space. Data communication. Standardized formats enable seamless communication between systems. Error handling. Clear representation aids in detecting and correcting errors. Number representation. Number representation is a set of symbols and rules to represent quantities and values. Text representation. It converts text into machine digestible forms such as vectorial representations. Image representation is encoding each pixel's color information in a grid form. Audio representation. It converts each sample of sound wave values into zeros and ones using the binary system. Video representation. It stores moving images as a sequence of digital frames using binary system. Encryption is used to protect data by converting it into an unreadable format. Only authorized users with the correct key can access the original data. Encryption. Encryption protects data by converting readable information into an unreadable form using a mathematical algorithm and a secret key. Only authorized users with the correct key can decrypt the data and read the original information, helping to keep data secure during storage and transmission. How encryption represents data. The process in which encryption algorithms such as RSA and AES are used to transform plain text into ciphertext. Symmetric encryption algorithms and asymmetric encryption algorithms are the keys of it. When data is stored and transmitted through various systems by encrypting data, you are adding an additional layer of protection that prevents unintentional and malicious data corruption. And it protects data from unauthorized access and tampering. Verifying a person's identity by granting access to a system, application, or resources is the authentication. Images are represented using pixels and color values, while sounds are represented as digital signals. Both are stored as binary data in the computer. Sound representation in computer system. Sound is a continuous analog wave which is produced by vibrations, and microphone convert these waves into electrical signals. Analog wave is measured per second and each sample is assigned a numerical value and converted the number into binary format. Sequence of binary numbers is stored in memory or files, and the computer converts the binary data into analog signal when it is played back. Compression reduces the size of the file, making storage and data transfer more efficient. It helps save space without significantly affecting quality. There are two main methods of compression: lossless compression and lossy compression. Lossless compression reduces the file size without losing any data. The compression file can be fully restored to its original form. Lossy compression achieves higher compression ratios by selectively discarding some data that is considered less perceptually important. Compression of data, reducing the size of digital data while preserving the essential information contained in them by using algorithms, making it simpler to store and more effective to transmit. Compression of image, a process applied to a graphics file to minimize its size in bits without degrading image quality below an acceptable threshold. Compression of sound, reducing the bit rate of audio signals, employing digital signal processing to minimize file sizes without significant loss of fidelity. Logic gates are basic building blocks of digital circuits. They perform simple logical operations like AND, OR, and NOT to process data. OR gate. It allows an output when any one condition is true, and it is used where multiple inputs can activate a system. AND gate. And it ensures all conditions are met before giving an output, and it is used in decision-making circuits. NOT gate. It reverses the input signal, used for signal inversion and control logic. NAND gate, used to block output when all inputs are true, and it acts as a universal gate to build other gates. NOR gate, produces output only when all inputs are true. It is used in control and memory circuits. XOR gate, detects when inputs are different, and it is used in error detection and comparison circuits. XNOR gate, it produces an output of 1 when both inputs are the same, and it is used for comparison to check whether two inputs are equal. This slide shows different types of computer networks. Each type is designed to connect devices over specific distances and for specific purposes. Types of network. Personal area network. It connects personal devices over a short range, and it enables data sharing between devices. Local area network. It shares resources like printers and files within a building, and it allows fast communication between computers. Metropolitan area network. It covers a city or town for high-speed communication, links smaller networks into a larger network. Wide area network. It connects computers over large geographical area, and it enables global communication. Enterprise private network provides secure and dedicated network for an organization's internal communication, and it connects different branches or offices of the same company privately. Global area network. It connects networks worldwide and supports global services and cloud computing. Computer networks use hardware, software, and transmission media to enable communication. Together, they allow data to be sent and received between devices. Now we'll see how hardware is used in computer networks. Network interface card. It connects a computer to a network by acting as a translator, and it converts digital data into signals for transmission and vice versa. Hub. It connects multiple devices by taking incoming data on one port and broadcasting it. Switches. It connects devices in a local network. Server. Sharing data or resources among multiple clients. Router. It connects different networks and forwarding data packets to their correct destination using IP addresses. Modem. It converts digital data, zeros and ones, from your computer into analog signals for transmission over lines. Firewalls. Inspects all incoming and outgoing traffic and you decide whether to allow or block it. See how software is used in computer networks. Network operating system. It makes sure multiple devices can work together seamlessly in a networked environment and allow computers within a network to communicate, share files, and resources. Network management software to provision, monitor, maintain, and secure computer networks by collecting data from devices. Protocols, the essential rules and standards that govern how devices communicate, ensuring they can exchange data reliably and efficiently. Security software, it acts as a layered defense, using tools like firewalls and antivirus to prevent unauthorized access. Virtual private network, an encrypted connection over the internet from a device to a network to ensure that sensitive data is safely transmitted. Transmission media. There are two types of transmission media, guided media and unguided media. Twisted pair cables. The primary medium for Ethernet, connecting devices like PCs, routers, and switches by transmitting data as electrical signals. Coaxial cable, primarily for broadband internet access and legacy systems to transmit high frequency electrical signals with minimal interference. Fiber optic cable. It, use, it uses light pulses through thin glass strands to transmit data at high speeds, forming network backbones, connecting data centers and bringing high bandwidth internet to homes. Unguided media. Radio waves allow devices to connect without cables by converting digital data into radio signals that travels through the air. Microwaves used for high capacity, long distance wireless communication and primarily through terrestrial point to point links and satellite links. Infrared radiation. It is used for short range line of sight wireless communication and primarily for connecting peripheral like mouse, keyboards and printers to PCs. This slide identifies various World Wide Web technologies. These technologies are used to create, manage and access content on the internet. There are Three main web technologies: web browsers, servers, internet protocols. Web servers. It retrieves information from other parts of web and displays it. It uses a piece of software called rendering engine to translate that data into texts and images. Web servers connected to the internet and enables data ex- to be exchanged with other devices connected to the web. To display website content such as text, images, videos, and applications to users by storing, processing, and delivering web pages. Internet Protocol: standardized sets of rules and procedures that govern how data is formatted, addressed, routed, and transmitted across networks. Network topology defines how devices are connected in a network. Different topologies are used to improve performance, reliability, and cost efficiency. Types of topology. Star topology. It enables high performance because each device has a direct link. It makes network upgrades easier without affecting other devices. Bus topology: reduce installation effort by using minimal effort. Works well for temporary or test networks. Ring topology gives equal access to all devices on the network, and it maintains consistent data flow at high traffic levels. Tree topology: it organizes devices into parent-child segments and simplifies network monitoring and control. Mesh topology: it supports secure data transmission through multiple paths, ideal for mission critical networks requiring consistent uptime. Hybrid topology combines two or more basic network layouts. It improves network flexibility by mixing designs, and it allows custom network layout for specific needs. Thank you for your time and attention.